ladies and gentlemen. Today I'm going to talk, it's quite a controversial, topic. Connectivity in rural areas. It's a very important subject. There are hundreds and thousands of initiatives which are happening in rural areas. There are so much of content being developed for rural areas across the globe, but everything gets stuck. All initiatives come to a standstill when it comes to connectivity. And I have been working on this very, very intensively for ICT and rural connectivity in the last at least 7 years. And there are some realities which I would like to bring and suggest a connectivity model for rural areas. It's just one of the suggestions, not that other technologies will not work. When I will be talking of this, I may be talking that why this is better than that another technology. But that's just a viewpoint, because both the models are designed for different scenarios. Okay, to start with, let's see. Coverage in rural areas is an opportunity. I think there's no dispute about this. Is this coverage happening at the pace people want it to? Certainly not. It's just not happening at the pace which the world requires it, creating a big digital divide. What then are the showstoppers? When things are moving so fast elsewhere, when technology exists to provide all these things, why it is not percolating down to rural areas? This is a big question, and that's the thing which I would like to analyze along with you. I'll do this with a case study, a very important case study which we did in India. Now, there are 4 rural realities which we have to analyze first. Rural reality number 1 is needs of rural areas. Urban users, require voice, data, video, and multimedia. And the trend is one device that will do everything. And the more that you can load onto that device, the better. On the other hand, in rural areas, it's the same folks as you and me, but they want the same type of services. But in rural areas, people are ready to compromise, and perhaps their priorities differ. First of all, they want to talk. Then they want some level of entertainment, and only after that would they think of data and internet and various other things. Though all these 3 get linked very closely to each other. The next important thing is user density per kilometer and ARPU. In urban areas, the user density per kilometer as well as the ARPU both are high to medium. Thus, any urban deployment, an operator can afford a high capex solution. He puts in a high capex and waits for a couple of years to recover it. In rural areas, it's a totally different story. The density of users who would be your targets or who would accept your connectivity or who really want your connectivity, at least to start with, is going to be very low. The ARPU or the return that you will get would be very low on an individual basis also. The paying capacity of the customer is low, so the whole model itself becomes low. And to succeed or even to start with in rural areas, you require a model that has very low capex. You cannot, while technology may give you solutions, but if the capex is going to be high, that won't sell in rural areas. Third reality is opportunity and competitive arena. In urban areas, there are lucrative business opportunities. Host of services can be given. And the ROI for an operator is assured. There's just no doubt. It's a gold mine for an operator. Of course, there are many operators and there is competition, but competition always brings in success, and that is through value-added services. In rural areas, on the other hand, it's a chicken and egg story. You know, the operators do not know about the return on investment. How can they invest millions of dollars when the ROI is not known, is not certain? The risks involved are tremendous. There are very few willing operators who are ready to go or to do in a concerted manner in these areas. And even amongst those that compete more on need-based applications, which is a good thing, and filling the nascent demand. There is demand. Even if an operator comes, if two operators come, any amount of operators come, there is so much demand in rural areas that it can digest all of them. Last and the most important reality of rural area is basic equipment design and connectivity models. Primarily, equipments are designed keeping urban requirements or high ARPU area requirements in mind. If you see any equipment designed, it's basically designed with high ARPU or urban areas in mind, where you have large user concentration, where you want small cell areas to be covered, where you require large capacity of the system. We have been all talking capacity because of the services. So you require systems with very huge capacity which relates to bandwidth. And it's more of a uniform cellular deployment because you can create an umbrella over such areas very easily. In addition, this deployment or realities of urban areas is backed with proven models. GSM networks are being deployed. It's a proven model. So there is no doubt in the mind of the operator or anyone who's trying to enter into these areas. On the other hand, in rural areas, the ground realities and requirements are just the opposite. Even the ground realities are different. And the anomaly comes from the fact that a lot of people, those who are even involved in planning or designing these equipments, have very little idea of what really rural areas of particularly developing countries are. And this mismatch is also supported by the fact that rural areas lack a proven deployment model. There's a lot of talk, there's no proven model wherein you can say, okay, use this and this is like you have in urban areas. Rural needs what we call a rural connectivity model, no matter what the applications are. It could be for voice, it could be for data, it could be for anything, multimedia, video, anything. It needs a rural connectivity model. Now what is this? What is this rural connectivity model? Now, to explain you this rural connectivity model, I'll take you along with me to one of the deployments we did in India, which by far till date is the largest wireless deployment of its kind in the world. This deployment was called Project Akshaya. Akshaya in the local language means infinite, because this was to give to the rural areas infinite opportunities. That was the aim of this. And this, as you see in this slide, this is the state of Kerala, where this was executed. In the 90s, Kerala achieved the unique distinction. This state achieved the unique distinction of becoming India's first fully literate state. There was no illiteracy in the state. So the big question came, what should we do next? This was the big question the government asked itself. And they came out with this project Akshaya, and the aim of this project was, Kerala realized that the future revolves around the net, and the prosperity of its people is linked to this net. So they set the aim of the project Akshaya was total e-literacy. Just like the phase 1, earlier they had total literacy. That means everyone could speak and write. In this, the aim of the project was total e-literacy in the state. Now what does this mean? In real term, it meant that at least one member of every family in the state will be made computer literate. And they said that's to start with. And when one member of the family is made computer literate, others will follow. When a housewife goes to a computer center to learn, to educate herself and become illiterate, the child also accompanies. And the child sees what is happening, and tomorrow he is the potential candidate to, train himself. The project was done in 2 phases. In phase 1, 600 cyber training centers were established, spread across 4,500 square kilometers in one of the districts of the state. The state has 14 districts, so this was a pilot which was done. And the idea was to create this 600 training centers, and no village was more than 2 kilometers away from a training center. And each training center was charged with the responsibility of educating one member of every family in that surrounding. And each cyber center had a LAN, of minimum 5 computers. There were some centers which had as much as 20 seats. In phase 2, see, you cannot do anything in charity. You have trained the people, now you want that network to be made self-sustainable. It should sustain itself. There is no idea, nothing will work. It has to be self-sustainable. To make it self-sustainable, they decided that they will provide, all these centers will be linked together into one wide area network, so that they can offer a bouquet of services, voice, data, video, multimedia, and what have you. And this phase, which involved connecting all these interconnects, providing connectivity to these, centers, was a challenge. And that's the challenge which we took on and which I am going to talk of. Many alternatives were considered. It was a tender, it was a global tender which came out for this. And we also, as a company, we considered many tenders. Cable solution, fiber, DSL, satellite, wireless and local loop, 3G, everything was considered. But there were shortcomings. And we found that none of these solutions will work for a number of reasons. Firstly, you cannot give a solution in rural areas at a price point at which it will not sell. You have to give a solution at a price point at which it will sell. So we worked backwards. We said this is the price point at which it will sell. Now let us see, can we tailor a solution to meet this price point? With that, concept, we said wireless is the only choice, but the big question remained. What is the right wireless technology that will enable this to happen? What is the right technology that will enable us to give this connectivity to the 600 cyber centers as a service provider, as an ISP, at the price point at which they will accept it, and at a price point at which we can sustain it further. This network was not being laid out for a demonstration. It was a live network to remain for years to come. Now, when we looked at the technologies, you have 2 types of, I don't call them technologies, topologies, solutions. One is a point-to-point solution. So you have a point-to-point wireless link. It's a very important component of any wireless network. And you have a point-to-multipoint, where you have one base station and you can address Again, a very important point or a component of any wireless network. But we found that this is not adequate. We found that we cannot, just based on these two technologies, deliver the results. And we came to the concept of multiple point-to-point. Or let us see what is the Guru Mantra. Guru Mantra means it's like the magic word. It's in Indian word for multiple. What is this? Multiple point-to-point. The magic word that compelled us to come out with this topology was extend. It was just extend. That was the magic word. And you do what? What is this extend? This implies extending the data cloud or the existing network or the PSTN, whatever you have, up to the villages or from the villages into the cloud. So you have to extend that network. And this cannot be done purely on point-to-point and point-to-multipoint topology. You just cannot do it on just these two topologies. If you look at this, point-to-point topology is like if you do it like this, it will be more like point-to-point is like a trunk of a tree and multiple point-to-point are the leaves. So if you do it purely on these two topologies, it's like a trunk having only leaves on top. And if you have a trunk which is only leaves on top, it's less like a tree and it's more like a bush. So it will not work. What this requires is a multiple point-to-point in between. And what is multiple point-to-point? It is like you have a trunk which is point-to-point, and then you branch out in different directions. So you have the branches and then you have the leaves. So if your basic topology of the network follows this, you can extend your cloud to the users and the users to the cloud. So with this in mind, we came out with this topology, and there are a lot of issues involved in this topology, technical issues. When you have multiple radios operating from one place, there are issues of interference and a host of other issues. So we tackled those issues. Now what is this architecture of this multiple point-to-point topology? The heart of this topology is this box, which is a base station, just like any other WiMAX base station or a 3G base station or whatever it is. It's a base station. This base station can sit directly on the cloud, or it could be connected to the cloud via RF link or even a satellite link. Particularly in African context, this could be a satellite link into a remote area. And having reached the remote area, now what do? You connect from here, you connect the various locations by point-to-point links. These are all point-to-point links, dedicated point-to-point links. It's like this. If I have a straw which has got one stem coming into the glass or a bottle of Coca-Cola, and I have 3 or 4 outlets and 4 people drinking into this glass of Coca-Cola, what will happen. As against this, if I have a straw for each 4 people separately, the results what will happen. So that's the concept behind this multiple point-to-point. And you have directional antennas at both ends. Moment you have directional antennas, you are gaining, you have high gains on the links, you are less prone to interference, and your network will be more reliable. As against if you have omnidirectional antennas at the base or a sectored antenna at the base. Now, having seen what is the Guru Mantra for the topology, now let us see what is the Guru Mantra for the model itself. And the first part of that is extend. So what do? You extend to a location close to the target area. From the cloud, you first, if this is the cloud, You come to the area, close to the area, your target area, close to the villages which you have to connect. This is done by point to point and multiple point to point. It's like you start a tree, you grow, the branches are there, so you've reached. It's like a tree when you see it in winters, they shed all its leaves, but it is reaching into those areas. And then you expand, from this network you expand. That means from these locations which are the target areas, from these locations to fill the needs of the target area. You provide connectivity from there to the various villages or, customers who fall within the target area. And this is done by point to multi-point radios. It could be WiMAX, Wi-Fi or any other, and also by multiple point to point. Okay, I'll just rush. Now this is the, in Akshaya, you see this is the cloud. We are extending, these are the locations which are close to the target areas. So from here we branch into different directions. Some places we can reach directly, some we reach through repeaters. And that's how, again, a branching, that's how you enter into the rural areas. And once you have reached there, you create an overlay, or you create, in that area you create point to multi-point. You reach to the customers using point to multi-point. It could be Wi-Fi, it could be WiMAX, or it could be any other technology. The customer called this solution a dream solution, too good to be true. We laid out a demonstration for them. They said it will be costly. And when the tender results were open, ours was the lowest bid and the highest bid was about 5 times more. Now this is a change phase of that district after, this is a school, a madrasa in that district. This is a change phase that connectivity brought in. What is the status of this today? While the network is in place, government offices and organizations like police, everyone is connecting onto that network. Because the network exists. It started with connecting the cyber centers, now everyone else in the government is connecting to this. Corporates and NGOs who are operating there are getting connected. The network has become fully sustainable and the ROI is almost returned. The franchisees, this was done on a franchisee model. There was a franchisee, village level entrepreneur. And, they're rolling out innovative applications. There are call centers working there, 10-seat call center. There's medical transcription going on. There's one entrepreneur, he's in one of the windows, he turns the PC upside, faces outside, and in the evening he shows movies to the people. There's a lot of innovation going on. And Kerala is heading to become India's first fully literate state, illiterate state. This is going to be a very, very big achievement. And I don't think there'll be any state in the world which will be able to, claim this. A pilot which started with 600 connects today is converted into a mega project where the government of India has planned to connect 100,000 citizen service centers across India. Same concept now spread across India. Same model. Now what's so special in this model? That it fits better the rural deployment scenarios that PMP are not optimized for. This is optimized for rural. It is designed to deliver the right capacities. Low capacity. 3 connects, 4 connects, 5 connects. That's the startup capacity. Your initial capex will be very low. It is designed for better addressing out-of-range customers. So if you have a multiple point-to-point, if customers are outside the range, you have to put another base station. Here the links can be any distance. They're all point-to-point links. They're all independent links. So you can have a short distance link, you can have this link of 30 kilometers, another of 40 kilometers. We have links in India up to 75 kilometers. Designed for better addressing a mix of low and high ARPU or SLA customers. You have low SLA customers, give them on Wi-Fi or some other technology. High SLA, dedicated bandwidth. He wants a 2 Mbps pipe dedicated to him. Give it on this point-to-point radio. designed for operational and functional efficiency. Obstruction. You know, in a multi-point, point-to-multi-point, if there is an obstruction, it becomes, you have to put another base station here. It adds to the capex. It is very costly base stations when it comes to WiMAX and other things. You know, so it becomes difficult to address this and these customers. Whereas in this, you put another point-to-point link, and here put a small device, that IDUG, you know, that base station which I showed you, black box. And here you are again. So you can, network can grow like a creeper, you know, like a vine grows. Interference. If there is an interfering, you know, radio here interfering with the base station, it can cause catastrophic failure on the base station. You know, or if it is at the far end, it can again cause problems. Latency of the whole system can go haywire. Whereas in this, if there is an interfering signal, it will affect only one link. Rest of the system will continue to work as if everything is normal. Service mix, I told you. Frequency mix. In WiMAX or anything, if you have gone in for 2.4 and tomorrow you want to go in for 2.5 or 5.8 or any other frequency, it requires a complete change in the system. In this, you can have links of 2.4, 5.8, everything can be mixed because it is independent. That box doesn't bother about, base station doesn't bother about the frequencies. The links are all point to point. And most important, this is designed for better integration with PMP systems like Wi-Fi. Now whether it is a WiMAX deployment or this thing, everyone is talking of that at the end point we'll put Wi-Fi. It's a local hotspot, small little this thing. Now if that be the case, what happens in WiMAX case? It is one multi-point system sitting on top of another multi-point system. You know, this Wi-Fi system is sitting on another point to multi-point system. And moment you do this, if there is any problem on this link because of which latency is going up or things like this, the effect on this will be at least 4 times more. So the quality of service, the services you can deliver, everything will be very badly affected as you load the system. Whereas in this, you know, this is sitting on a point-to-point. Everywhere that the hotspot will sit, it will be a point-to-point link. So you don't have the system problem of multi-point sitting on another multi-point. Now this is another example. Rural telemedicine project. You have these point-to-point links and you have the multiple point-to-point links. You cannot do such a deployment by, according to me, you cannot do it in WiMAX or 3G or any other technology. Summary. The low capex model answers the rural infrastructure dilemma of chicken and egg. It addresses the rural connectivity challenge regardless of the application and last mile topology. You can use anything in the last mile. At the end of it, you can have Wi-Fi, you can have anything else. But the basic network is strong, resilient. It is a sustainable, field-proven model that requires very little technical expertise, so the OPEX are low. It is capable of delivering all types of voice, data, multimedia. Every service can be, because you are having independent pipes. There are no shared pipes anywhere. It is easily replicable anywhere in the world. And it integrates very well with VSAT deployments to reach very, very remote areas. To conclude, I would say, don't think the urban way. Think the opposite. Think the rural way. And when I say this, why you need to think the rural way, let me show you something. You see, any equipment or anything is designed to do a particular application. This key has been designed to open this lock. If I use it for this purpose, it is a lock it is designed to open a lock, a stationary lock, a lock on a door. So there is no problem, I will be able to open it. But moment I start using it for something more than what it is designed, I am extending its capabilities. And I will find it little difficult to open it, but I will be able to open it. But as this process of using it extending the capabilities of the product to deliver something for which it is not designed increases, my problems of opening this also increase. You know. But when I reach that stage where it is like, I'm having a product designed for urban and trying to use it in rural areas, it's going to create headaches. So the model is first get close to the target area, start connecting them, and now as they are connected, the demand for service will grow, and so will the returns on investment. And lastly, before I conclude, now we are on 2008. Why we need to invest in rural? And the answer is, this is a picture of Microsoft Corporation 1978. Would you have invested in this? Okay, in 1978. Today we all feel, why should we invest in rural areas? Believe me, if diamonds exist anywhere in telecom, they exist in rural areas. I have seen it. Thank you.
Thanks, Mr. Gupta.
Thank you.
A very good, inspiring case study. Questions, comments from the audience? Yes, please. One question over there. Can you hand the mic to our friend? Another question here, yes.
My question is on the issue of spectrum. What spectrum are you using, and what are the licensing issues around that?
See, this model has no licensing issues at all. Because in this model, we have used unlicensed frequencies. We have used a mix of 2.4 and 5.7 ISM bands. And in countries like India, and I am sure many places elsewhere also, the entire 5.2 upwards, 5.2, 5.3, 5.4 is very shortly going to become unlicensed. So, in rural areas, you don't have any issues of spectrum. You can go the unlicensed way.
One more question from here. Sorry, I couldn't see with the lights so bright. Yes.
Dylan Danita from the Change Studio in London and consulting partner for Business Excellence.
Mike's here.
On the presentation, firstly, a fantastic initiative, and I think one that everybody here will be only too happy to replicate in Africa and other emerging markets. Secondly, I think you closed on a very, very valid point, which I relate to the most innovative of countries and organizations, and that is to think the opposite way. It's the only way that we can be truly innovative. My question is around the funding for projects like this. Where did the funding for the project to make Kerala illiterate come from? Was it a public-private partnership, or was it fully funded by the infrastructure providers, or was it government funded?
Okay. See, this pilot was done fully funded by the government. Government invited a tender, and they said, this is the network to be laid out, these are the deliverables, there were, certain things. And everyone responded, the lowest who had quoted was got the, and we had, of course, the lowest. And the point which I told you about this was that, see the difference between the lowest bid and the highest bid. 5 times the difference. Okay, because, it is not because we were using some different products, we were using some different unique radios, or we were using something, it was same things off-the-shelf products which are available in the market. But we used it, we bundled it in a manner at which we could get it at that price point. So that is the crux of this. Don't think the routine way. We all think the routine way. Okay, 3G, WiMAX, all big hypes, going on around the world. They're not for rural areas. They will come to rural areas 5 years down the line. But what happens till that period? From now to that 5 years, do this. And at that time, superimpose these, bigger technologies. They would have matured, prices would have come down, everything would have. But start with this.
Fantastic.
Last question, please. Yes, someone had a hand at the back there. Yes, you.
Thank you. Very enlightening. I'm from the government of Namibia, and we have declared rural connectivity as a priority. So this was very interesting. I would like to now As a government official, I normally think put a cap on that doesn't have money, sort of a lot of money. You said that it can be replicated, and I was wondering whether and talking about the model now, that can be replicated. Do you have maybe a toolkit or something available that as governments in Africa, for instance, we can look at and study and then possibly take it further? Thank you.
Yeah. See, when I say it is a model, if you see what I told you, I try to explain you what is this model. This model is like you have a cloud, you have a target area, you extend to the target area, and then you start connecting from there. That is the basic model. Now, my talk, though I am from Radwin, a wireless company, and we did all this, was not focused on a particular product. You can use many products for this, as long as they follow the basic. They have to be point-to-point, they have to be multiple point-to-point, they have to be PMP. It's this mix which will get you there. And, this same model, now if you want to apply this model, it's not that it is for rural areas. You can apply this model in an urban area, in a semi-urban area. Only you have to compress it. If in rural areas it is extending over 20 kilometers, in urban areas it will extend over 5 kilometers. Model will remain same. Things will remain same. So it's a replicable model, and just as a word of rural connectivity is a thing which is very passionate to me. I have worked a lot of this with lots of organizations in India and outside. And if any one of you, sir, require any this thing, please send me an email, and it will be a pleasure to send you or to put you on the right track.
A round of applause, please, for Mr. Gupta for a very good, well thought out, radical but replicable model of rural access.